8 participants, of whom 4 of whom are us.
I think most people arrived kind of just after 10 last week. So.
Bum 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 bum. Yep.
Just give it till I passed and then we can get started.
Here, lectures are 5 past to 5 to. It seems that in Germany it's usual for lectures to be 2 hours, and they go from 1/4 1 hour to 1/4 the hour after next. And everyone knows this. It's really disturbing when you turn up for your seminar, to give your seminar on the hour, and no one comes along.
Well, I mean, I quite like the sound of it starting a 1/4 of an hour late and finishing a 1/4 of an hour early. I'm not so sure I like the sound of the 2 hours.
It was explained to me that this was because German universities were traditionally or typically quite large physically, and so there was a good half hour it took, but was deemed to be the right amount of time to get from one place to another. But certainly on campus here, with the whole campus being available for room bookings, you see some folks scurrying around between the two times.
Yeah, I remember around about the point that they introduced that, and I had one lecture which was in the Rankin building and then another one which is in the Kelvin building. Getting between the two in 10 minutes was actually a challenge. I don't know whether it's better now that there are more crossings across University Avenue, but yeah, it used to be a bit of a...
And someone...
from one to the other.
Someone buttering on after 5-2 would be unpopular. Look, I've got to go. Okay.
Just for everybody who's here already, I'll drop the link to the notes, the software carpentry notes for this session into the chat, but I'll put them again in a couple of minutes once we're getting started as well. So I think it would be useful to use this time, if you can, just to check the setup step on those pages, because there is a file which you need to download and unzip. So it would be useful to have that ready.
Yes, the item 0 on that schedule is download the raw materials.
so I make that very nearly 5 past. So, welcome back to Software Carpentry for the second session this week. So this is session 2 of 4. And today Norman will be taking the session again and covering a tool called Make, which is designed for automating processes which you might have to repeat numerous times in a very predictable and repeatable manner. So it's principally used for doing things like compiling software, but it can be used for a whole variety of other things. And I think Norman will touch on some of the other situations where it might be useful in natural sciences and physics particularly, and things like, for example, compiling your thesis in LaTeX. So we won't be covering the LaTeX aspect of it, but we will be covering how you go about setting these things up. So I will just drop a link in the chat to the notes which Norman will be working through. As I said a few minutes ago to everybody, there is a step 0 on there about where you have to download a file and unzip it. So it would be sensible to get started on trying to do that as soon as you can. Otherwise, I shall hand over to Norman. One other thing. The recording for last week's session I'm about to put online. I apologise for not having been able to do that before now. I've been travelling and haven't really had access to the appropriate machinery to do that. But I will do that during this session this morning, and I will circulate a link on the website. Without further ado, though, I will hand over to Norman. So thanks, everyone.
Hello, everybody. I'm not sure that. Oh yeah, good. Hello, everybody, and thanks for getting back this second week. As Daniel mentioned, I'm doing this session again, the second of 4. In previous years, we've done this a slightly different order with the shell, then the version control, which comes next week, the Make, and then the Python session. This time, for various logistical reasons, we've swapped the second and third sessions around. But in some ways, it makes better sense, because although you get me back to back, then Daniel back to back, the Make is a fairly natural follow on from the shell scripting stuff, because I find myself writing bits of Makefile more often than I find myself writing shell scripts. I use the shell all the time, all day, every day. But the writing of shell scripts is actually a little less common, and that's because most of the things that I want to automate to be able to repeat, be able to repeat variations, are things which end up being more useful to express that automation in the form of a Makefile. As Daniel said, Make is really quite an old program now. I mean, it's from the dawn of Unix time almost. It was originally intended for building software, and it's still used for that extensively. But it's also always been usable for other tasks to do with whatever automation and repetition was useful. And slightly more of the time that I use it is for configuration tasks, for repetitive things rather than for building software. Not least because software programming languages like Python don't actually have a compiling step, so that motivation has slightly gone. But there are alternatives to Make. There are other programs which do similar things, and CMake. There are others, but none of them has quite managed to get to displace Make. And that's partly because it's actually a very nice program. I mean, it just works as it is, and I hope that will become clear as I go through. So enough high-level motivation. As with last time, what I'm going to do is power ahead through the material in a fairly brisk way. I hope that the demonstrators are on hand in the chat and in the breakout rooms if you have problems. So do keep up. What we'll do is we'll assemble a Makefile over the course of the session, which will have all of the important features of Make. So it's fairly important that you keep up with editing your copy of that Makefile as we go along. I think that the timing that has been suggested on see that, yes. The timing that has been suggested on the SUPA carpentry lesson is not unreasonable. I noticed that they have removed some stuff from the end of that from previous years. I might be able to busk that at the end because it was quite useful, but it should be that we'll be able to get to all the way through this in the 3 hours without too much difficulty. So, let us get going. Are there any questions? Well, generally, if there are any questions or comments, shout out in the chat. What I'll tend to do is talk away, then look at the chat. Talk away, look at the chat. So if the things that are in the chat outstanding, that's a great, say them when it occurs to you, and either the demonstrator will jump in, or else, if it's more appropriate, I'll come in and address those points at a suitable break. So I hope to see lots of chatter in the chat. Okay, let us get going. Just while I'm here, I'll say a few more words about what the point is. We'll write a very simple basic Makefile, which already at that point will illustrate quite a large fraction of the relevant syntax of Make. Make is not a complicated program. The next few parts of the course are really about how we make that simple Makefile that we'll write in section 2. How we make that just tidier and neater, and how we again avoid repetition. And by avoiding repetition, we avoid the risk of making mistakes, because a large part of the point of a tool like Make is the same as the point of shell scripts. It's to avoid mistakes. It's to avoid redundant work. It's to be able to be confident that you're doing the same thing now that you did when you got your wonderful results last week and last year, and just to save yourself time and effort. So that really is the basic plan. We'll get a large fraction of the work done in section 2, and then tune it in the sections after that. Okay, let's get going. What we're going to do, I hope that you will have downloaded the zip file that's in the setup instructions on that first page, and if you open it up, you'll see inside it. I'll just sorry, we're doing some rehearsal beforehand. If I show the contents of this directory, this is the unpacked zip file. Ignore that. We see a file called 3 Python scripts, and a directory called books, which has just inadvertently changed the size of that window. I didn't want to. A file called books, a directory called books, which has the text of 3 books inside it. As you can see, they're quite decent sized files. We are not going. Well, just to show you the contents. These Python scripts are just Python scripts.
Sorry, Norman.
Yeah.
We can't see the terminal window.
Thank you. Do shout out, of course, whenever that happens. So there is the contents of the unzipped directory. The books directory has the text of some books in it. Just to show you the skim through the contents, the Python scripts are just Python scripts. There's nothing exotic in them. We're not going to worry about how those Python scripts are constructed. We're just going to use them as black boxes for the purposes of this. So I hope that you've got something that looks a bit like that in your on your screen. So, returning to the notes, we have a directory structure like this, and our goal is to, well, the idea is that there's a thing called Zipf's law, which it talks about the relative frequency of words in text of decent size, and so the idea of this is to verify that for the books that are the text of which is in the books directory. And we're going to do that using some tools which will count the words in there. And this is an obvious proxy for a more realistic task that you might well, a more realistic data analysis task that you might well have. So the first step is to use the these Python scripts to get basic data. What we do there is Python count words, that Python count tab to fill that out. Books isles.txt isles.dat. We run that script. It runs, and what we see is, if we look at the first 5 lines of this isles.dat, is a file which contains the words that are in the, well, what that script does is it breaks up the text in the isles.txt file, breaks up into words, and counts the number of words, analyzes. We discover that there are 3,822 occurrences of the word "the" in this text, and that is 6.6 times the frequency of the lowest. That's the relative frequency. So let's isles.dat. Okay, I'm not sure what 1 is on this scale. Come to think of it, but the third column is, the important thing about it is the third column is a column of relative frequencies. So if we look at this isles.dat, or look at the first 5 lines, we see that the third column is the number of occurrences as a percentage of the total number of words in the file. So that 6.7% of the words in the isles.txt file are the word "the", 4.3% of the word "of", and so on. And we can see that the percentage of the word of the word "the" is about, well, 1.5 times the number of the percentage of the fraction of the word of the times that the word "of" appears. These results are not particularly important. The result is how do we manipulate these. So there's with that isles.dat file present, we can do other things as well. Python, use one of the other scripts, plot counts isles.dat, and give an argument ASCII, and we get a little ASCII art version of the relative distribution. And we can do things like blah 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 show, and you can't see it, but on my screen a graphic has appeared showing that as not an ASCII art, but a rather nice bar chart. And you can just close that window down when it's finished. So I hope you're following along and doing the same thing, and verifying that the same thing is happening on your screen. And we can do similarly. We can say we can ask for that image not on screen but as a ping file. Okay, now let's do the same thing for not the isles file, but the abyss.txt file. And we'll put that into a file called abyss.dat. We now have 2 files, isles.dat and abyss.dat. And there's another program, Python Python, I can't type, test zip abyss.dat, isles.dat, and it does its stuff, and the ratio of the most common and the second most common word is something not too far off, too close enough for astronomy. So what have we done here? What I've been doing is I've been showing you, illustrating how the various little scripts in this directory work together to turn the data that's in the books directory into the our results tableau. That's, where is it? This, which proves our theory to be correct. And as I say, that's a very common workflow in the sort of science that you're doing. You have a data file, you perform some sort of analysis in that data file, you save the results of that analysis, you plot graphs, you save graphs, you make a summary table, and so on. So there's steps here which are interrelated, and it's the interrelation that's the key thing here. But as you see, I've been doing all these various steps just by typing out the commands, and the tab key helps. But I have more than once got a bit confused about what file I'm using. That's clearly error prone. If I decide to change the script in some way, I've got to remember to regenerate the output files that I have generated already. I want to tidy things up. I want to get rid of these generated files. How do I do that without messing, without accidentally deleting my data, and so on. And so that's okay if there are just a few data files. I mean, in this case, we have what is it? We have 4 data files. If you only have 4 data files to work with, then data analysis is not the main part of your PhD. But if you have 10 or 20 or 100 or 10,000 data files to analyze, then typing all these commands out is just not a good way to spend your life. Also, if these produce the results immediately, but if an analysis run took several seconds, or minutes or hours, then you wouldn't want to be sitting there waiting patiently for them to finish. So, is there a smarter way of doing this? If you were paying attention last time, then your answer will be yes, you write a shell script. So let's write a shell script. We'll write a shell script called run pipeline. Python, and we'll duplicate what we got, what we did last time. What the commands I typed out before. Count words, .py, books, isles, .txt, isles.dat. Delete that line, break it back again, an abyss, and then we write Python test zip .py abyss.dat isles.dat to results.txt. The notes have more steps involved. My point can be made with just these. I would, of course, no, stop. Should add some a little bit of basic documentation at the top. Exit that. We do want to save that file. And we do sh run pipeline.sh. What's happened? What else has gone wrong? What I've done is here I cut and paste and have done the wrong thing. So even writing the shell script, I've made a mistake. But by trying to save myself the labour of typing that whole command out. So I save and modify buffer. Yes, save that. Run the pipeline, and it does its stuff, and we end up with results.txt, which is the summary file that we got before. And that's very nice. So that's a good thing. That's not a bad approach. Excuse me. It's a good approach because I know that if I run that script again, I'll get the same results. I'll just rerun my whole pipeline, data analysis pipeline, get the same results, and that's good. And so that shell script I could preserve in my version control system that you're going to learn about next week. I could put in my notes the version of today works and save it one way or another. So I have made my science reproducible, and that's a key thing. And I have saved myself the labour of typing all those commands, and reassured myself that when I run the shell script the second time, I'm typing exactly the same commands as the first time. There aren't any mistakes. I'm not accidentally analysing the IOLs.txt book and putting the results in the abyss.dat output file. So this is not a bad approach. The problem comes when, for example, I add another text file in books. What do? I could perhaps go back and edit the script and cut and paste this line again, make the edits, try and make sure that I make those edits and don't make mistakes, and then I run the whole thing again. But what happens there is that the entire pipeline gets run again. So if I were to what are the let's see, excuse me, Sierra.txt. See if I were to go back in here and write Sierra.txt, Sierra.dat, Sierra.dat. Have I typed everything correctly? I think I have. txt. Yep, I think so. Exit save modify buffer. Yes. Then sure, run pipeline, and it does its stuff. Cat results.txt, and I now have the data, the results from the Sierra file in there as well. But as you can see, I had to think carefully to make sure that I had cut and pasted everything correctly. I had to make changes in multiple places, which presents ample opportunity for error, and every opportunity for error is an opportunity I will take to make a mistake. And it also, which is not good. But separately, when I reran the analysis in this step here, I did the whole analysis. I didn't just redo the analysis for the Sierra file. I redid the Abyss one and the IELTS one as well. Now that didn't matter in this case because it takes seconds to do. But if you have a more serious data analysis problem, then that is a problem. You don't want to do that. So the notes pick this up and mention that you could be a bit smarter and use a loop such as here. That's true, and you could you might be overthinking. But what I could do is I could make this list of files a variable and reuse that in multiple places. That's also true. There are ways you can improve this shell script to make it less error prone, less to make it less error, but a bit more elegant. If you don't want to if you correctly don't want to redo the analysis again and again and again, then you can do things like commenting down bits of the script. You can say, let's just comment those bits out. They're still in my file. I know what to do. All I have to do is remember to uncomment them when I next want to do this. But you will forget to uncomment them, and you will be left thinking, have I regenerated this or not? And be looking at timestamps and trying to work out whether or not things have got. And there are solutions to all these problems, blah, blah, blah. But I hope I have made the point that although you can solve this problem with a shell script, and that's not a bad approach, shell scripts are clever things, although you can do that, it is not the best way. I'm setting this up, of course, to lead to the inevitable conclusion that the best way is to use make, and that's what we're going to do. We're going to look at in the next chapter. So what I will look at, I'll look at the chat. I see there are some. Yes, there. At the bottom of the setup notes, there was a mention that you have to have NumPy and Matplotlib installed. I think that's some Python problems that have been presumably solved in the either in the chat or in breakout rooms. Are there any questions that people are burning to ask at this point? Is everyone happy? Good. But I see a thumbs up. I'll take that as representative of the majority. Excellent. Okay. Then let us advance. Just for yes, as I said before, Make is quite an old program now, but it works beautifully. I mean, it's a slightly disturbing example of a program that just hasn't been much bettered. What we are doing, just by the way, and this won't affect many people, what we're using is a particular dialect of Make called GNU Make. On a couple of operating systems, you might find a different dialect of Make. I mention that just to lodge in your head the idea that there is more than one dialect of this, but almost all of you can immediately forget that remark, because the chances of you're unlikely to come across that problem until at some point when you have enough sophistication to take it in your stride. Onward. So, some goals. How do I write a simple Makefile is basically what we're doing. So what we're going to do here is write a simple Makefile which gets us doing the majority of the things that we want to be able to do quite swiftly here. So what we need to do is type along with me and edit a file called Makefile. Now the name is important. It's Makefile with a capital M. We'll see why it's important in a moment. We'll edit this file, and we'll just follow the suggestions in the notes. Count words. Isles.dat, books, isles.txt, new line, and tab, not spaces.
We're not seeing your...
Oh, thank you. Thank you. So count words, isles.dat colon, isles is a books, isles.txt, new line, and tab, not spaces, tab, Python countwords.py, books, isles.txt, isles.dat. Now, here, type along with me. Here we are actually seeing a large fraction of the syntax of Make just in those 3 lines. Make is not a complicated language, as I say, but all the important parts are there. What you're seeing is that lines which start with a hash character are comments. They're there to remind you what this bit does. That's always useful, because in only the most trivial cases is it completely obvious what things do. It's always useful to remind yourself what's going on. This this second line in this file is expressed as a dependency. It says that the file isles.dat colon depends on books/isles.txt. The file isles.dat depends on the file isles.txt. What does depends mean? It means that it is created by or updated by an operation on isles.txt. It must be newer than isles.txt. It's an output from processing of the file isles.txt. How do we get the file isles.dat from isles.txt? Below the dependency line is a rules line, which starts with a tab. And you can see if I right arrow one space, I jump over the whole tab. If those were space characters, that I would have to right arrow a number of times. And the rest of the line is a shell command. It's what you could type, and what I did type before to produce the file isles.dat from the file isles.txt. So the dependency line, in a sense, makes a promise that the rules line shows make how to keep. And I think that's a very good way of thinking about it. If isles.dat needs to be updated, this is how to do it. Okay, so I hope you got that written. We'll save that file as Makefile. You can see it's there. And what we'll do is we will type. Let's first of all get rid of the chunk. I remove star.dat, star.ping, remove results.txt. We'll have a way of automating this in a while. So we're back to the starting point. And then we'll type just make. Good. That seemed simple. You should see the same thing happening when you do the same thing. When we take make runs, it looks for a file called Makefile with a capital M in the current directory. That's why you called it that. Why you give it that name, and it asks. It looks at the Makefile, says that it has to make sure that isles.dat is up to date with respect to isles.t. Up to date means exists and is newer than. Because we deleted all the dat files, the file isles.dat does not exist. So make realizes it has to remake that file. How does it do it? It runs the rule, the command in the rule stanza, and echoes it, and we see that there is now a file isles.dat in this directory, exactly as before. So this is a slightly long way of getting to where we got to last time. If I did things like made that into spaces and did make, I would get an error, which is a rather hard to interpret error. This is one of those cases where the error message is telling the truth, but is unintelligible, because that's the truth from Make's point of view. That's Make's way of saying that on line 3 of the Makefile, see, it is helpful to the extent it tells you what line the error was. There is a problem, and the problem is that I'd put spaces there rather than tabs. Has everyone got that far? Okay, I'll it looks like there's things happening in the breakout rooms. I will trust that will go smoothly. Anything to shout out about that? No. Excellent. Now, the Makefile doesn't have to be called Makefile. It can be called something different. There are cases when that's useful. I'm going to mention that just to lodge the idea in your head, but we will not make a useful advantage of that. Okay, that's good. Let's try make again. Now, it says isles.dat update. What it means is that if we look at the content of this directory, isles.dat 25 February 1035 is newer than isles.txt 2019. So it exists and is newer than the file it depends on. Remember that in the Makefile we said isles.dat must exist and be newer than books isles.txt. It currently is, so when we say make says there's nothing for me to do. And that's important, because if generating that data file, if analysing the data, processing the data to turn it into the data file was an expensive operation, it takes seconds or minutes or hours to do, it's good that make it recognise that it has nothing to do. Let's see. Say we did that, and we actually deliberately edited IELTS.txt. So now we touch the file. All the command touch does is prod the file so to make no change but update its timestamp. Now the file IELTS.dat IELTS.txt IELTS.dat is that age, and the file books IELTS.txt is that date. Now it's as if we updated the source file IELTS.txt. Now IELTS.dat is no longer newer than IELTS.txt, so we say make realize it has to remake do the work again and regenerate the dat file. So let's extend this. As you remember, we have multiple data files here. So let's do the same thing for one of the other data one of the other files, abyss.dat, books abyss.txt, Python count words, .py books, abyss.txt, abyss.dat. We exit that, and we now type make, and nothing happens. We were rather hoping that would regenerate abyss.dat, because we have both of those targets in the make file. So what happens? What's happened is that, I think I haven't told you, is that make will, by default, try to satisfy the first target in the file. The first rule in the file. All the rules in the file, we only have two at present, but all the rules in the file are not ordered. The ordering doesn't matter, with the exception of the first rule in the file. Because if you, give make the instruction to run, but don't tell it what to make, what it does is it presumes you mean the first target in the file. So in this file, the first target is IELTS.dat. It runs through it. It sees that the file IELTS.dat is up to date, and it does nothing else. If we specifically say make abyss.dat, it does its stuff. If we do that again, it has nothing to do. So that's an important point, that all the rules in the make file are unordered, apart from number one. And another point to make is that if we say make countwords.py, it says and it hasn't been told anything about countwords.py. So as far as it's concerned, there's nothing to be done. There's nothing to be done, and I've done all of it. Stop bothering me. Is what that is. So there are two different things here. One, I don't know what you're talking about. It's what this message translates at. One, and the other is I've done everything that he's done. So those are two different things. In the second case, in the case of abyss.dat and IELTS.dat, make has been told something about those files, and it's done it. In the second case, make just doesn't know anything about things it has to do for countwords.py. Now, the next thing what we want to do is make another addition to the make file. At the bottom, as I say, the order doesn't matter, but it's conventional for this to be at the bottom. We make a file, a target called clean, which doesn't depend on anything, but has as its rule rmsf star.dat. And if you recall, what the star does is expands to everything ending in .dat, and the F option to RM says even if there's nothing to delete, even if you have no work to do, don't bother me with an error. Don't exit with an error. So we'll exit with that. Makefile, and now we'll say make, nothing to do, make clean. It removes all the DAT files, and they've been tidied away in the expected fashion. And this is a clever thing to do because what this means is I can just type make clean, and all the regeneratable things disappear, and that's useful because it means I won't delete something I'm not supposed to delete. It's very easy to say, oh, rm blah 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 star dot thing. Oh, one of those was my data files. If instead you abstract that away to the clean target, then you are writing down for yourself what clean looks like, what things can be removed safely in a way that means you don't have to think about it. So I'll just type make clean. I can't think what else to do. I'll just clean things up. I'll type make clean again, and nothing's happening each of those times because there are no DAT files. But I can do it again and again because I know that there's nothing. I can't shoot myself in the foot that way. So now a problem here is that this is a sort of a hack, a sort of Makefile hack. If we look at that file, what we're seeing is, remember that I said here that the dependency like that says, it sets up a promise which the second line shows make how to keep. It says this is how to make isles.dat newer than isles.txt. This is how to do it. What this is saying, this line here, is this is how to make a thing called clean. But it's a lie, because the rule here doesn't make it. So, but it has the effect of doing the thing that we want to happen when we clean things up. And that's a very conventional hack of make. That this is not a thing you want to have made. It's a sort of command that you want executed. But this can break, because say I had a file called clean. Well, let's have let's do make. So we've got this out.dat. So you have a file called clean. It doesn't have any. It doesn't have any size. It just exists like that. Now I say make clean, meaning I want to delete all the DAT files, and it says, oh, it's up to date, because it's looked at clean, said clean exists. I have nothing to do, and it hasn't actually done the deleting stuff we wanted. And that's because that's where this little sort of Makefile hack slightly breaks, because we're saying this is how to make the file clean. We've made the file clean, and Maker's got a bit confused. What we do therefore is we say, actually no, this is a slightly deliberate lie. We'll say this is not a real target. It's a phony target. It's a fake target, a pretend target. And the way we do that is that with this slightly weird syntax, we say .phony : clean, and that's it's written like that because just so that it fits in with the Makefile syntax. But that's the way, that's like unexpected way that we say this is not a real target. I don't expect you to actually make this. So now if we save that, then this file clean still exists. But if we say make clean, it knows that's just a mistake. It just ignores that as a target and does the make clean command, or pseudo command, as we expect. So I'll get rid of that file. So the problem that's solving doesn't often actually happen, but is useful nonetheless, because what's happened here is that I have in this Makefile declared loud and clear that this phony target is a phony target. It exists purely to be executed and not to be made. So it's an executable documentation in a way. And that's a theme of Make as a script, executable documentation. I'm just going to check the timings. How are we getting on with in terms of timings? We're doing well. So now I'm going to edit this further. I'm going to create another phony target called DATs. And DATs will depend on IELTS.dat, abyss.dat. Down here, this phony target clean didn't depend on anything. It would always run no matter what. Here, I'm saying that this phony target DATs depends on IELTS.dat and abyss.dat. So what it's saying is this phony target DATs is quotes up to date, and that's strictly in scare quotes because this is a phony target. It's up to date if IELTS.dat and abyss.dat are up to date. What constitutes them being up to date? Well, IELTS.dat is up to date if it's newer than IELTS.txt. Abyss.dat is up to date if it's newer than abyss.txt. So now, if we say make, the first target in the Makefile is this new DATs target. So we just make, then both of those DATs targets are made up to date. How are they made up to date? They're made up to date by looking at the corresponding rules and the corresponding actions being run. If we removed, say, abyss.dat, so that we now have IELTS.dat and abyss.dat and type make again, then it's only, at this point, it's only abyss.dat that's missing. So make has worked that out. All it has to redo, the only work it has to do again is the work to generate the abyss.dat. It doesn't have to redo anything for IELTS.dat. So already what we've done is we have expressed the structure of our data in a way which is might make sense to us, might be useful, but also crucially is executable documentation in the sense that it means that that make can make everything good. What constitutes make everything good? Everything is good if the first target in the file is up to date. In this case, it's up to date if these are up to date. These are up to date if these dependencies are satisfied, and these actions are how to make that so. What else do we have? So if we go back to the web page, what we've done here, what we have here is an expression of the dependency graph of of our data. This DATs target depends on the individual .dat targets. They depend on the corresponding .txt targets. So what I want you to do now is, in the Makefile that you've been keeping up with, I hope, I want you to write a new rule for last.dat, which is the result of processing last.txt in the same way as before. Add something, update the DATs target so that becomes part of the set of files that you want to be kept up to date. And if you think back, we summarized our results by using an action like this. Write a rule for results.txt which does that, and put that rule at the top of the Makefile so that it becomes the target number 1, and that's the default target. So have a go with that. Let's have 5 minutes of a breather while you're doing that. It's now 10:53. Take 5 minutes to write that, and perhaps stretch your shoulders. turned off at 6. And so we said, I think there's some wrong atmosphere. So it's a vertical path for a bit of it should be working. Oh, of course, yes. Yep. Okay. See you. Hello everyone. So let's see how we get on there. What we had to do was, well, I see that folk were having sorting out some Python problems in the breakout rooms. Python's always a bit of a nightmare there. I can talk about Python problems and dependencies until the proverbial cows come home, but I hope everyone's getting sorted. So, right, 2 new rules here. Will be but a new rule for last.dat. Last.dat books last.txt. Tab Python count words.py books last.txt last.dat. Write a new rule for results.txt. And we want that to be at the top of the makefile, so it becomes the default target. Now that before results.txt can run, it has to each of the dat files has to be present, so because it's processing them. Isles.dat will list. So in these other ones here, we've listed a single dependency for each of the for the targets. Although for this phony target, we've said that the phony target dat depends on multiple dependencies. But here we'll have isles.dat, abyss.dat, and last.dat. And the action is python test zipf.py abyss.dat, isles.dat, and last.dat to results.txt. We want to, the clean target removes all the dat files. We don't have to fiddle with that, but we include results.dat at the bottom. So I hope you can see the changes I've made. Save that, yes. And now, if we do make, now we think, will let's do the right thing. What we'll do, we'll say, we'll give the option -n to make. This is a lot of, this is all these option names are conventional. There are no rules about what options do what, but there are some conventions, and quite often the option n means, I'm not sure what n stands for, nothing or no work or something like that. It means show me what you would have done. And so, but without actually doing it. And if you're editing a makefile, this can be useful or if someone gives you a makefile and says just run this to build all the software, it can be useful to see what's about to happen before it actually does. So what happens here is we discover that when we take make, the last.dat file will be generated. The other ones won't be because they already exist and are up to date, and the testzip.py script will be run to produce the actual results. So let's actually do that. Results.txt exists, cat results.txt, and we see what we expect. So now what we see is we have in this new makefile we have a different, larger dependency graph. Results.txt file is now the point of our makefile. Most makefiles have a point, a thing that they are making. In this case, the results.txt is the thing. It depends on each of the dat files. We said that explicitly by listing those dat files as the dependencies of the target results.txt, and each of those in turn depends on the txt files that they depend on. Now we haven't said that results.txt depends on those text files. Ought we to? Well, let's see whether we need to. Let's update one of those. What's happened here? Whoops. Go. Where am I? Terminal frozen. What's happening here? My terminal seems to be frozen for some odd reason. Let's just see. Okay, puzzlement all around here. Who knows what? Books, let's say last.txt. So we artificially make that newer and say make. Now what's happened here is that going back here, we see that although last.txt isn't listed as a dependency of results.txt, last.dat is a dependency of last.txt, and last.dat is a dependency of results.txt. So in order for results to be up to date, it has to be newer than an up-to-date last.dat, and in order for last.dat to be up to date, it has to be newer than last.txt. So these dependencies chain in what is, if you think about it, the way you'd rather hope. So in order for a file to be up to date, it must be newer than its dependencies, and all those dependencies must themselves be up to date. And so what make can do, therefore, is work out now this is a very simple dependency graph. What make can do is work out the possibly quite intricate dependency graph, a dependency graph that's intricate enough that it would confuse you and me. It can work out what's up to date, everything that's what up to date means, and do the minimal set of actions to make that so. Again, that's not a big challenge for something like this, but it does rapidly become a challenge when you have a set of configuration files, for example, which must be edited with configuration parameters to give a certain result, and other data files must blah blah blah. You know, you can imagine that a dependency graph would become quite complicated. And as long as you have expressed that set of dependencies accurately in the make file, make will just take care of it. And that's really the big thing about make. If you've expressed the dependencies carefully, it'll just work. So this has been what we said at the beginning of this file was at the beginning of this this section, which was slightly only 1 minute over time. I think we're doing very, very well here. What we have here in the in this make file, as I said, we have quite a large fraction of the syntax of make in this make file. We have comments. We've been a bit slack about comments elsewhere. We have dependencies. We have actions, together forming a rule. We have multiple dependencies. We have phony dependencies, where the thing being listed as a dependency isn't expected to actually exist there and there. We have chained dependencies, where something depends on things which themselves have dependencies. And although the order of all the rules in the file doesn't matter, there is an exception to that, which is that the first rule is the rule that make will aim to satisfy if it's invoked with no arguments. And almost all the time we do invoke make with no argument. We just say make it so, make the good things happen. So I hope everyone is on the same page, as it were, with respect to having a make file that looks very much like that. Minor variations are fine, but something that looks a lot like that is a good place to be at this point. I'll quickly glance at the chat. Okay, things look happy there. Right. Any questions about that? Now is a good time to ask them. Am I going too slowly? Am I going too quickly? Any views there? I'll take silence as an assertion of perfection. I see thumbs up. That's good. Right, onward. On to the next section, which just a few minutes. Right, let us go back to this is the section that I'm working through just now. Okay. We have this makefile here. Now, you will instantly say, but what is this nonsense you've been talking about avoiding repetition? There's repetition all over that. There's all sorts of opportunities for cut and paste errors. The same rule is appearing in 3 different places. If I want to add another data file to process, I have to cut and paste a whole extra stanza of that file. Where's the benefit here? These are excellent points, which we want to address now. So, a key thing is the principle of don't repeat yourself. DRY, don't repeat yourself. And because there's repetition everywhere. So how do we address that? How do we avoid this repetition? Well, one place where there's repetition is in the very first stanza. This results.txt, the dependency line promises that make can make result.txt from these .dat files. The action shows how to do it. But what if I accidentally mistyped that and set the results.tzt? Make wouldn't object. It doesn't care. It doesn't inspect. Make doesn't look at the act lines of shell script that it is executing. It just does what it's told. So this action would break the promise. You promised in the dependency line that this action makes results.txt. What you've actually done is make results.tzt. It's a silly typo, just a thing to debug, but you can avoid that by giving the results here not as results.t whatever, but as the command, the variable $@. Now, if you think back to the last week, we had shell variables which were blah equals blah, and we referred to them with dollar with a dollar sign, dollar in front of the variable name. This is similar, but, and this is an important thing to realize when writing makefiles, this is not a shell variable. It looks like a shell variable, it's dollar something, but it's not a shell variable. It's a make variable. So it's make that substitutes that variable in before it hands this command over to the shell to actually do the work. So this is called an automatic variable, which means the target, whatever it appears before the colon here, is what that $@ will expand to. But we also see that there is repetition here. The abs.dat, als.dat, last.dat, which is the same as the set of dependencies. An obvious extra case where we could mess things up by mistyping, or by simply adding one of the dependencies but forgetting to add it to the action rule. So instead of those, we'll use another automatic variable, $caret. And that's easy to remember. Caret is pointing up to the line above. So here, the $caret is expanded by make, not by the shell, by make, to mean the set of dependencies on the previous line, and $@ is expanded by make to refer to the whatever the dependency of the of the rule is. So let's save that. Make clean. We can always do make clean because we know that's always safe. Now if we do make will again make the first target in the file, and here the last line, it's done exactly the right thing. Oh, hey, nice. That the command in the Makefile was testzip $caret piping results to $at, and what has happened is make has expanded that to exactly what we wanted, to process the dependencies, send the result to the target. And now, if we change the dependencies in the Makefile, we don't have to change anything else. We have to make an edit in one place. Don't repeat yourself means make edits in one place, because you can't mess that up. You can't be inconsistent with it if there's only one thing to edit. So now, if we were to well, there's a little exercise here. What would happen if you now execute touch star.dat make results.txt? Spend 10 seconds thinking which of those 4 options would happen in that case. Nothing, everything recreated, the dat file is recreated, or results.txt recreated. Now, if we were terribly well organised, I'd have a little Zoom poll at this point. But what I'll do instead is say it's not nothing, because if the dat files are touched, then they become newer than the results.txt file, which Make interprets as meaning the results.txt file has to be regenerated. So something would happen. But the dat files are now, if you touch the dat files, they are now newer than the corresponding .txt files. They're more newer than the result.txt files, but Make just it's just interested in them being newer. So as far as Make's concerned, there's nothing to do to regenerate the .dat files if they are already newer than the corresponding .txt files. So it's not the case that everything was regenerated. Certainly the .dat files would be generated. Now, the .dat files specifically wouldn't be regenerated because they are newer. But the results.txt file would be regenerated because by touching the .dat files, you have made them newer than their target. So the target results.txt is now no longer newer than its dependencies, so the corresponding action is executed and results.txt is made. Let's just verify that. Touch star.dat make, and indeed it's only the result.txt file that's regenerated at this point. Oh, sorry. There we go. I did touch star.dat make, and then it was only that file that was regenerated. Now, in the notes, it mentions that this $caret means all the dependencies of the current rule. So it's the lines on the things on the line above is how you remember what that means. In fact, that's fairly uncommon to use that. There's another automatic variable which is much more commonly used, which is $angle bracket, which means the first dependency of the current rule. And you think, why would that make a difference? It ends up being a useful thing to do. So that and we can take advantage of that if we go back to here and again edit the Makefile, and so we can now write Python count.words. This sends output to $at, and the input is $angle bracket. Now, in this case, because there's only one dependency, we could write that. That wouldn't be wrong. But as I say, the caret automatic variable is less often used, and in this case, if we were to, for some reason, put something else here, then this would suddenly become wrong. It would become wrong because it would then add both of those dependencies to the action line, generating a wrong call of the script countwords.py. So instead, we guard against that by saying that, by being more explicit and saying we want the one thing which is at the beginning of this list of dependencies. And we can do the same thing with the other rules, and you can see what the next step is going to be already. So these become less error prone because they use only automatic variables rather than specific things. Okay, so if we save that, and there's nothing to do. But if we were to remove abyss.dat and do make, it would regenerate abyss.dat and then regenerate results.txt because one of the dependencies has now become out of date. So the key things there are this notion of automatic variables, which saves us typing, and part of the point is to save our wear and tear on our weary fingers, but also because saving typing avoids repeating ourselves, which means it helps us not make mistakes. And so these automatic variables at angle bracket and occasionally useful, the complete set of caret for the complete set of dependencies of the current rule. Let's look at the chat. I wrote results in the first line rather than listing all data. An excellent instinct. That's exactly what you would want to. What I hoped someone would say. That's the bright idea I hoped someone would have. That's exactly the right instinct. Turns out to be wrong, but we're about to come on to say why that. Not wrong. It doesn't work, but it's not the cleverest way of doing that. So we're about to come on to look at that. So I'm very glad someone had that bright idea, because it's exactly the bright idea that we're looking for folk to have. Right instinct. Okay, let's move on to dependencies on data and code. So we're not going to address that particular point quite yet. We're going to just complicate our Makefile a little bit more before simplifying it. This whole lesson is a sort of ebb and flow of complicating the Makefile, then simplifying it, complicating it, then simplifying it, and we end up with a Makefile which has no repetitions in it at all. So what we have is something like this, which I hope what you have looks similar to that. Now, what happens if we are doing our work and we realise that the way we're generating this well, let's say make DATs. Okay, that's brilliant for that. Say we realise there's a bug in CountWords, and we fix it by editing CountWords, and we'll simulate that by saying we'll touch the countwords.py so it becomes up to date. It's as if we were editing it. Okay, so what we need to do is that has changed how the .dat files are regenerated. So let's do make DATs again. Oh, we were rather hoping that because we've changed the way DAT files are being generated, we actually really need to regenerate the .dat files themselves. But make doesn't do that. Why not? Because, well, we haven't told it that that's important. Make is smart in some ways, but it's not telepathic. So how do we do that? We have to explicitly tell make that that isles.dat, abyss.dat, and last.dat do depend on the script file as well. And here you can see why doing $caret here would be wrong, because in that case, if iles.dat were to be regenerated, then it's both of those. Let's write down what would happen there. Yes, make which one was it? Iles make -n iles.dat, and we see that because this second argument in the Makefile was $caret, it has inserted both the dependencies, creating a wrong invocation of this countwords.py command. So this is why it is, and this is more often the case, $bracket is the correct thing to do rather than $caret. So now that produces the correct thing, and if we just do make, then the right thing happens. And what the right thing is each of these .dat files being regenerated, because although the txt files haven't changed, the countwords.py script that does the work has changed, and because they are now up to date in the way they weren't before, the results.txt action has to be run in order to make that up to date. And so now the dependency graph has become more complicated. Now and it reminds me that if we were to go back here, we let's not say that. If we go back here, we see that the dependency graph had become more complicated. Results.txt depends on these dat files. These dat files depend on the corresponding txt files. You can't see corresponding. I can't gesture toward bits of the. I can't gesture toward bits of the of that window in a way that appears in the zoom. But you see that abyss.dat, iles.dat and last.dat depend on the corresponding .txt files, but also depend on countwords.py, and we have expressed that in the Makefile. Okay. What? And there's another example to think with. I won't. If you're reviewing these notes later, I encourage you to go through these these little exercises and work things out. Now, in this example here, the script which testzips.py, which generates results.txt, is also a dependency of results.txt. If we change the script testzips.py, we need to regenerate results.txt. Okay, so the obvious thing to do is to go back here and say testzip.py. Why is that wrong? It's wrong because this is wrong. Because now, because that $caret is there, that testzip.py is scooped up into the action line in a way that is wrong. We can't run testzip.py on a data file consisting of testzip.py. And we're about to. So one way of dealing with that is to say there's more one way of dealing with that. One way of dealing with it is to change the order of the dependencies. Say Python run the first dependency like that, and then star.dat in that way. What's happening here is now we are correctly stating that the result.txt file, result.txt depends on these four things: a script and three .dat files. and we are assembling the action line by make expanding that dollar angle bracket with the first of the dependencies, the dollar at by the target, and the shell expanding the wildcard star.dat here. And that's an important, useful point to make, which is that these dollar variables here are expanded by make, but the wildcard is expanded by the shell when the shell is given this command to execute by make. And it's useful to have that distinction of who's expanding what in your head as you write action files. That's not the best way of doing that, and we still haven't answered the question that came up in the chat at the end of the last section about the best way of handling these DAT files. But that shows that you do have to be aware of what these, of just what these automatic variables do actually expand to. Okay, any other questions? Nope, that seems good. I'll go ahead and look at how we're doing for time. Are we still good for time? We're doing very well for time. Good. So, onward. So, pattern rules. So I'm looking at this section now. So we have seen that there's repetition, and we don't like repetition. Both because it wears out our fingers, and because it introduces scope for mistakes, which we will certainly pick up. So we see a pattern here, and this is something that we have to that prompts us to think: can I get rid of can I take advantage of that repetition to avoid typing? The answer is yes. What we'll do at the top of the file, we'll add a rule which looks a bit like that, like those .dat rules, but isn't the same. We'll say %.dat books / %.txt can't type count words .py tab python count words .py dollar angle bracket star.dat. Okay. Now, that's what the notes are suggesting. I'm not going to type that. I'm going to type this because, well, I'll do what the notes say, and then I'll come back and contradict them in a moment. What this says is it says there's a pattern here, and we can capture it in this stanza here. The pattern with make, the wildcard, if you like, is this % character. It says for something.dat, you should take it. There's a dependency books / the same something.txt and countwords.py, and in order to satisfy that dependency, to make that target newer than both of these dependencies, you have to run python countwords.py first dependency, which is this, and a dat file. And here we're seeing another automatic variable, which is $, and $, expands to the thing that % expands to. So now we can get rid of these repeated. We'll delete those in a moment. We'll comment out. We'll get rid of these deleted .dat individual .dat rules, and just go with this pattern rule, where this line here is up to there. Something you've seen before, the dollar angle bracket. The dollar star is something that is a bit new. So let's save that. And now we will make clean, make, and the same thing happens. So that's good. So these lines here, these which generate the .dat, are being generated not by the explicit rules that we had before, but by the pattern rules. So we're saying that results.dat depends on these .dat things. How do we make those? How do we make last.dat up to date? We look to see if there is a book/last.txt which is older than it. If there is, then we know what to do next. Another thing I'll mention is that I just typed make. If you notice, I just typed make. I didn't type make results.txt. I just typed make. But you say, surely this is now the first rule in the Makefile. No, the first rule in the Makefile, from Make's point of view, is the first non-pattern rule. So it's conventional for pattern rules. It's not necessary. The pattern rules could be anywhere, but it is fairly conventional for all the pattern rules to be at the top of the Makefile. That's showing the it's building up a knowledge base for Make of how to do useful things. So the first non-pattern rule is still results.txt. So when I just say make, it's this target that Make attempts to bring up to date. It looks for these, it finds pattern rules to tell it how to make these up to date. This tells Make how to do those, and it goes ahead and does it. Expanding, in this case, the $star, somewhat confusingly, the star here does not. It's not the shell wildcard. It's a make pattern variable. The star expands to whatever a percent expanded to. Now, as I say, that's not what I would write. I think that while that usefully illustrates the I think single remaining automatic variable $star, what I would write in that case is just $at, because what that last argument to the count words script is the thing we're making. So there again, if we IELTS.dat and type make, then as before, IELTS.dat is remade, and the results.txt is consequently remade as well. So that's a matter of style, I think, rather than syntax. It also means that writing star.dat is not wrong, but I look at that and I go, oh, something's missing. Where's the $at? My eye immediately goes, how am I producing the target in this thing? So just to stop myself looking at that and being startled, I would always use that, express that as with the at variable rather than anything cleverer. Right. Let's look back here. Whoops, I found them right to yes. So the Makefile. So was I looking at the right? Was I showing the right screen? It doesn't matter. The point is that. In fact, yes. So in the sample Makefile, they have included the pattern rule in the body of the text. As I say, I don't often put pattern rules there because it's easy to miss them. Having a block of pattern rules at the top, I find makes it a lot clearer to a reader, me, when I come back and try and work out what this rule is doing. Also, it makes it clear to me that this has been generated by a pattern rule rather than anything clever. So I always put pattern rules at the top. I have said that I would write that differently, but that's fine. And this is a point which I don't think we've mentioned before. What you can see here, I think in the Makefile that I've written, I have. Sorry, I'll get rid of these extra lines here. I've written rm-isf star.dat results.dat, but this rather useful illustrates here that that's not the only way you can do that. You can do rm star.dat and rm result.txt, and that -f means if this file doesn't exist, don't complain about it, don't moan about it. But it is also useful illustrates that you can have more than one action line in a rule. So there are two action lines in this rule, both of them prefixed by a tab. So for a stanza consists of a dependency, a target dependencies, and one or more, or actually zero or more action lines separated by tabs, and no blank lines. Blank lines separate stanzas. So that's pattern rules, and we're now closer to having to describing all the syntax of make. What time is it? 11:40. I think that let's have a look. Is there anything in the? Okay, that's a good question. What happens if a target meets the conditions for two rules? Or do you mean what happens if we have what happens there? Well, typically what happens there is in that case, what happens there is you realise you made a mistake. I mean, I think make won't complain about that. I think what it'll do is it'll pay attention to this rule here. So generally, you wouldn't want to write something like this, but you could find yourself writing something like this. What's the difference? What that is, again, you wouldn't often see that, but it is sometimes relevant. What this is saying is results.txt depends on these things, and this is how to remake it. What this is saying is results.txt depends on this something else, but it doesn't give any instruction on how to make it. What happens there is that is as if you typed something else there. So what this second action rule here, what this second dependency here does, is it simply adds another dependency to the rule here. Why would you do that? You typically wouldn't, but if, for example, a sort of place where you would do something like that is, for example, saying abyss.dat depends on foo details, for example. Right. There, we save that. Now, will this actually do what I expect it to do? Make. So abyss.dat exists. Not. Let's go back here. Let's comment that for the moment. Save that. Make. Everything's up to date. Good. Now, uncomment this again. No, so let's leave the comment out and say, was it touch foo details. So for some reason, there's extra bit of dependencies that is relevant here. Now we do make, nothing needs done. If we go back and edit this and uncomment this and do make, then the extra dependency that abyss.dat depends, for some reason we haven't specified, on this extra file foo details, means make goes, oh, I do need to regenerate abyss.dat in this case. So that's a case where abyss.dat had some dependencies acquired from this pattern rule. We've also injected a couple of other dependencies just here. I think in this case, if you did add further rule such as echo wibble to abyss.dat, yes, touch foo details and make. Now, yeah, so this I think answered the long way of answering your question. Now what's happened is something different has happened here. Because if we go back to this, in that case, with that stanza not present, then the way that we made abyss.dat was purely according to this pattern rule. When we added that dependency, we said, oh, and by the way, it depends on foo details as well. But we didn't change anything about how the abyss.dat was generated. When we actually added an action rule to that, we say, oh, and I'm overriding what the rule is here. So with this version as it is now, isles.dat and last.dat are regenerated according to the pattern rule here. But abyss.dat is a special case. It's regenerated according to this special rule here. But if I remove the action rule, then all I'm doing is saying, I'm not changing the rule for how do you make abyss.dat, I'm just saying, and by the way, it also depends on this. Was that the sort of thing that you were asking, Fred? That's the thing you meant. I hope so. Another question, for more than one action, can we run them in parallel? Yes, you can. A good question, and a very important question in some contexts. Let's get rid of that. Yes, make clean. What we'll now do is, try to do is make, I think it's option J. I don't know why I had to give away a mnemonic for J. That does the same work, but you may have noticed it was slightly faster in the sense that it did those three commands in parallel because they could be done. It broke off 3 separate shells to do that work, but it waited until they were all finished before it ran that one. Why did it do that? Because the Makefile has said that result.txt depends on these .dat files, so they have to be present before the test.zips.py script runs. So make knows therefore that it can run these 3 in parallel, and when you give the option J, you're saying you carry on. You anything you can do in parallel, you do in parallel. But it waits until they're finished before later, subsequently, running the last thing which uses those outputs. So the answer I think take it that was the question. Thank you, Aaron. I knew that had to be something like that. Jobs. So that answer, Sian, is yes. You can run certain things in parallel, if that's what you meant. Now, you can't always do that because if you say make minus J, then make will take full advantage of that, and it will try and run in parallel everything it can. And sometimes, if with a complicated Makefile, you can tie yourself in knots that way. If you haven't expressed the dependencies fully, then make is not psychic. It won't deduce dependencies, so it will go ahead and do things in parallel, even though because you haven't told it not to. There are still there's network dependencies such that it can't actually do that. So getting a Makefile bleeding. So getting Makefile working is step one. Getting it working with -j typically requires some extra work, because that will uncover some dependencies that you didn't realise that you hadn't expressed, and which you hadn't realised. So those are two excellent. I'm very glad for both those questions came up, because they're both useful points to make about how dependencies are calculated, and that you can inject extra dependencies even though there's a pattern rule, and it is possible, though slightly more tricky than in practice slightly more tricky than you might expect, to get multiple parallel processing working. Good, thanks for those. Okay. Next. And now we're finally coming back to the point. Oh, actually, is that a good point? It's 11:49. I think we are, good for timing here. Yes, I think we're bang on schedule. My God, I'm good. We're bang on schedule, but I think that nonetheless it would be useful to have just a 5-minute break just to let my voice recover. So 11:49. Let's take 4 or 5 minutes just to stretch our shoulders and take some deep breaths. Okay, back in 4 or 5 minutes. Okay, let's get going again. Pressing on, we'll look at this, one of the last bits of Makefile syntax where we can again further avoid duplication in an obsessive endeavour to avoid all duplication in the Makefile. So we have our Makefile, Makefile, but this name of the script, countwords.py, appears in two places, two whole places. My God, the repetition is barely tolerable. Now, there isn't a way of referring to. There's an automatic variable which refers to this automatic variable $angle bracket refers to the first dependency. There isn't a whole set of other variables that exist which refer to different dependencies in the list. So that's not. I'm not about to introduce another variable which does clever things about picking which variable to pick. So that's not the technique we're going to use to remove this redundancy. Oops. Sorry, cancel. Instead, I'm going to use a variable, a non-automatic variable, to remove this redundancy. We'll call it count source, countwords.py. So the syntax is fairly obvious. Variable equals value, and there's no quoting. There's no complication here. You can have more than one thing on the right hand side and make it very dumb about it. It divides the line into before and after equal sign, and the variable before is set equal to the value afterwards. There's no quoting. There's no make it very bad at space handling, by the way. How do we use that? $round bracket count count source $round bracket count source, and if we now do make rm abyss.dat make. Really? Right, that's interesting. Because I had inadvertently added an extra character there. That's actually quite an interesting point. I fumbled the dependencies there by inadvertently adding an extra character to that, and that meant that that pattern line didn't match. And rather than say give an error message like that pattern doesn't match, what Make did was said there's no rule to make. I have no idea what you're talking about. Go away, I'm not listening to you. I can't work out when that's from. It couldn't find a rule, and what it said was I can't find a rule. What it should have said was I think you've mistyped this. So it is an acknowledged defect of Make that sometimes error messages are though accurate, not always very helpful. That's what I should have typed. Now if I type Make, the right thing happens. So abyss.dat, we said was dependent on count source, which is this, and we use count source in the rule. So that's that. Note that again, this is a make variable reference, not a shell variable reference. So the brackets are inserted by make before being given to the shell. That would be wrong. That Make would interpret that as a reference to the variable C, and it would try to expand C, fail to do so, and leave so what happened there is if we did rm abyss.dat and make, you see, it tried to expand that as it tried to expand $C as, well, it did expand to nothing. Then outsource is what it gave to the shell, and the shell went what? So make can be confusing sometimes in the error messages it gives, and it's important to remember that the $signs here are being expanded by make rather than by the shell. Again, conventionally, I put all the variables at the top of the file, a couple of two blank lines, then the rules, pattern rules, two blank lines, and then the rules proper, the non-pattern rules, with the first one being results.txt. And I mentioned that the results.txt file is the first rule. It's also conventional to have a rule called all, which is the first rule, which is typically the first rule in the file, and to say that depends on results.txt. Now, we haven't really added anything there, but what this means is that there's a couple of things that happen here. First, it's the first rule in the file. So the target all is the phony target all is the target that will be executed by default. How do we bring all up to date? All is up to date if result.txt is up to date. How is result.txt up to date? Result.txt is up to date when this is true, when this dependency is satisfied. So nothing really has changed there, except that it means we can write make all. And in larger Makefiles, that can be a useful thing to have, and you should get into the habit of having an all rule in your Makefile. It may or may not be the first rule in the file, but if someone comes along who is used to Makefiles and sees you have a Makefile, then the thing they might do is the fingers might automatically type make all, because that will usually be taken to mean make everything that is makeable here. So all I'm doing there is mentioning a convention that it's conventional for there to be an all rule, and its dependencies are all the things that are that need to be made in this Makefile. But this sequence is conventional: variables, couple blank lines, one or more pattern rules, blank lines, and then the proper business. Now the notes mentioned that the language that we can further abstract this by saying that the language we are, I'm going to say Python here. Python equals Python. Why am I doing this? I'm doing that because it might well, it might well be that this is actually some of you will see in real Makefiles. It might well be that on a particular platform, it turns out that the default Python is Python 2. That's rare these days, but it might happen. And so you might have to say, oh, actually to get Python 3, because I need Python 3, I have to use Python 3 all the time. If I use that as a variable and set that in one place, then I can be confident that it will be used all the way through the Makefile consistently, and that I will have some Python 2, some Python 3. Or if I have to put a special path if I have to do something complicated to get that path there, then that's a sensible place to do it. Now, what we don't really want to do in that case is say is that in the Makefile. If we are distributing a software kit or a data analysis pipeline to our colleagues, we don't want to encourage them to fiddle with the Makefile if we don't trust them to do the right thing. So in that case, what we would probably do is, let's put that aside for the moment, and we'll say we'll add another Makefile. Well, not quite a Makefile, but another file called config.mk. Again, the name is purely conventional, and say Python equals Python 3. Same. And what we would cancel. What we'd probably do is say fill this in with the correct path to Python 3. Or maybe your script depended on Python 3.8, and you have to tell your colleague to do something special to fill in the right path to Python 3. We'll save that, and we'll go back to our Makefile, and rather than having this line here, we'll say include config.make. Yes. And now make clean. Now if we make, we see that what has happened is that the Makefile has read in this config.make, taken note of the variables defined in there, and by making one change in one place in this config.make file, we have been able to tune the way that this pipeline works for all of the Python that these run. That's quite a useful technique, and it splits up the main part of the code. What you're doing here is programming. The main part of the code is in the make file, and a separate file which has the configuration information that you need, and that's useful partly because it makes it clear in your head which is code, which is configuration. But also, if you're sharing this with your colleagues, as you should do, good scientists share. If you're sharing this with your colleagues, you can say, there's a complicated make file, ignore it, edit the config.make with the details that work on your computer. And what you probably do is you might have lots of instructions in here. You can find this out by doing blah. You might well have lots of notes in this file to guide your colleague to how to make these various configuration changes. And there are other ways, more complicated ways of doing this sort of thing. But the general point is that you're separating off code and configuration. And the notes give more elaborate examples, which I don't find particularly convincing always. You can overdo. I think this is going over the top, personally. I see the point they're making, but I think this is being true to make a point that the variables can be defined in terms of other variables, but and I wouldn't put that in the config.make file because that's not something you'd expect your colleague, the recipient of your generosity, to be fiddling with. But the point being made, the relevance of that remark in the notes is just to say you can have variables defined in other variables and do complicated things there. Okay, that is variables. We're almost at the end of the new syntax. Thank you very much. You're exactly right, and that wasn't my deliberate mistake. That was actually an error, but it did let me say that make is not always terribly helpful when it comes to its error messages. They're always accurate, but not always helpful. Okay, onward and upward. Functions. Now, I think the most important thing about this is not the functions as such, but as a detail that we'll come on to. There are other bits of redundancy we can eliminate. This is the Makefile as they suggested. The Makefile I've built up is slightly different from that because I have opinions about good taste and good style, which differ because they are lunatics. Everyone who, when it comes to matters of taste, all those who disagree with it are lunatics, we must recall. But what we have here is we do have a list of the DAT files we're generating, which is baked into the Makefile. So if we add another .dat file, a list of text files rather. I mean, where are we? Yes, we have a list of files that we process. This list of DAT files is what we list here. and here. And so if we want to add another text file to the collection of things that we analyze, we have to edit it here and here. Now, of course, what we could do is have a variable which expands to these three dat files and include that here and have the same effect. And that, incidentally, is why. So I'll show you what that would look like. Let's go back to the Makefile. What that would look like is where would I want to put that? I think I would want to put that near the top. Equals IELTS dot dat, abyss dot dat, and last dot dat. And look, I forgot these just in I've accidentally provided a good illustration. This list of .dat files and this list of .dat files have got out of sync. So if I do make dats, I wouldn't.
I think you've maybe got the wrong screen up.
There you go. Thank you. So what I did there was I opened the Makefile again, and made this variable here, dats equal IELTS.dat, abyss.dat, and last.dat. And I'm about to replace this sequence of dat files here, but I realise that I have already accidentally made a good point, which is that I have already allowed this list of dependencies of the dats for new target to get out of sync with the actual list of dependencies of the results target. So if I did make dats, I would think, oh, I'm making all the dat files. But I wouldn't be, because I would be missing the last.dat, because I forgot to add it here when I added it to here. What we could do is therefore just do dats, and here dats. And this answers the question that was raised in the chat a few chapters ago. It's not useful to have a dependency on this for new target dats. I think it might work. It almost certainly would work, but it's more explicit to have a dependency on a variable like this, which expands to a number of dat files. What this means is that if we wanted to add another file to the list of files in books to be processed, we'd only have to make the change in one place. But we would have to do that edit. We would have to make that change. And also, there's a bit of a disconnect between this dats here and this dats here, which we probably should change that to dats as well. It does also mean that we do have to edit the Makefile if we add a new book to analyze. Now, we could, of course, put this dats hive it off into this config.make file, and so that we clearly identify the config.make as the file to edit. But there's a smarter way of doing that, which is to use another feature of make. I think this is basically the last bit of make syntax that I'm going to talk about, which uses wildcards to generate this variable value for us. So what I'll do, I'll create a variable called txt files, and its value will be $wildcard books /.txt. And what that does is this invokes a make function called wildcard, which expands the argument it's given to, and the whole thing expands to a literal version of of this with the wildcard expanded. Now I'm going to do something that's slightly out of sequence here. I'm going to here write echo dats equals dats. We'll save that and say make results.txt. result.txt, make -n. And here, because I added that echo command to the actions for making result.txt, it shows me the command being executed here. It shows me what I would do. So this is actually a quite handy technique for debugging variable expansions when they get a bit confusing. And you can see that $dats variable expands to the literal list of files of files that were. Oh, sorry, I didn't mean data. I meant text files. Sorry. Sorry, I'm illustrating the wrong thing. Nope. Nano is horrible. Echo txt files equals txt files x. And now if I make option n without doing anything, I can see that the txt files variable expands to this literal list of files in the books directory, including this books.sierra.txt, which we haven't mentioned up to this point. So there was another file in there which we had completely forgotten about because we hadn't added it to our variables in here. So that's what this txt files expands to. But that prompts us to realise that this dat is wrong. This list of dat files should include sierra.dat as well. So how do we? So we don't want to maintain the dats list and the txt files list separately. How do we fix that? What we do is we want to generate the dats variable from the txt files variable. I see that the notes mention this as dat files. I would just call it dats. Let's use another function called patsubst, pattern substitution. And this again uses this similar sort of pattern language as before, and says for everything that looks like books something.txt, turn that into something.dat for each of the things in txt files. Now, I'll have more to say about the syntax of that in a moment. What's happening here is it says dat is the value of txt files, but with everything that looks like books something.txt replaced by something.dat. And so now if we save that and give the same make without doing anything, we see that dats has turned into the list of books slash something.txt turned into something.dat. So that if we actually, both in that echo command and in the actual argument of the file, so that if we remove the -n and actually do the command, we see that the results.txt file does in fact have all four files, all four data files represented. So going back here, we're using this patsubst variable. Now, if you were to say that is a really confusing way of expressing that, I would heartily agree with you. I can never remember what order the various commands, various arguments come in patsubst. And that's one reason why I never use that particular form of it. What I instead say is dats equals $, txt files, but with books star.txt replaced by star.dat. That has more punctuation in it, but I personally find that much more readable than the other version. Opinions may differ there, and I won't think you're mad if your opinion differs from mine. I think you're a little strange, but I don't think you're mad if your opinion differs from mine. I certainly find that a lot more readable and easier to type. But it has the same effect. If we remove results and type make, again, TXT files become is what we what before. DATS is what it was before. What we saw before, and the correct sequence of arguments is indeed given to the shell. That if we're doing this echo business, a last thing to mention there is that we can actually suppress that echoing of the command with this @ symbol. Not often useful, but sometimes we would have seen the echo without as here the command being echoed. Let's get rid of that. Okay, now that is good. What that also means is that when we come to the cleanup line, and I'll write this as rm minus f again, we can write that as DATS. That is better than using a wildcard there. Why is it better? Because explicitness is generally better than implicitness. If I left that as star.dat, then it would then the as things stand right now, that would have the same effect. But if in a moment I thought, oh, there's another DAT file that I want to include in here, which I've got from this other source, I'll just drop it in here for the moment, even though it's not generated from the books file. Whenever I then did make clean, the action as it was expressed before was remove all the DAT files, and so this other one, which just happened to have a similar name, would be scooped up in that wildcard and deleted as well. This way, I know what's in the DATS variable, and I'm deleting just what's there. That's generally it's prudent to be aim for explicitness here. Now, so what we can do is come out here, make clean. All these things are removed. What we have here is I might have results.dat. That was the wrong thing. It should be results.txt. And we have there what we expect on with that food details, which is also a thing I just added just to illustrate another point. Take make, and all the things that we want to happen. So that is almost us. In a second, I'm just going to check something. Okay. We're actually being a very, very good time. What I will do now is I will go back to the notes and point out that here is the dependency graph that we have ended up with. The results.txt file depends on these various DAT files, the list of which is generated dynamically. Each of those DAT files depends on a corresponding .txt file, and the rule which associates a .dat file with a .txt file is generated through a pattern. Each of those depends on the countwords.py script, and that is a well thought through and entirely repeatable analysis pipeline, which is all managed through a really very short. It doesn't quite fit on my on that 24-line screen, but through a very short Makefile. And even if each of those analysis runs took an age, and we wanted them to run in parallel, so make j as you saw, it set off all four of the count words things running at the same time, and wait for them all to finish before putting the dots together. So even if those analysis runs took quite a long time, it wouldn't be doing any extra work that it didn't have to do. Now, the last thing I want to do. So at this point, I will say that that is sort of all of Make. If you go and look at the Make manual, and you can find that fairly easily on GNU.org /make/manual. I think the URL. You can find it easily. It's quite a big manual, and it includes all sorts of extra things, other details, other remarks, and other functions, as well as the wildcard and the pat subs thing, and other automatic variables and stuff. There's quite a lot you could read there, and I encourage you to have a look at the manual, because always a good idea to look at the manual. However, with most software systems, it's useful to read the manual and take full advantage of everything that's there. There's all sorts of cleverness that is documented in manuals, and using all of it is generally a good idea. I think it's good advice with Make not to get carried away. A good Makefile is quite a simple Makefile, and the amount that I've described to you here, the amount that is the well chosen subset of the Make functionality that's in these notes, which I agree with, is basically all the functionality that you need. You can do more complicated things, but when you start using all of Make's functionality, your Makefile ends up looking largely incomprehensible. It's very easy to write Makefiles that look incomprehensible. And the way you do that is by saying, oh, this Make is a wonderful thing, I'll use all the possibilities, I'll end up with the explosion of punctuation factory, which doesn't actually help, I don't think. I myself tend to aim for the structure of the Makefile to be quite simple. I'm willing to write quite complicated shell commands in the actions to do exotic things, but I try to keep the Makefile itself simple, and that's a balancing act. And some we may well disagree that it is reasonable to use all the functionality of Make immediately, but I find it more useful, and I have found it more useful in the last few decades, to keep Makefiles simple as possible, because they can be a bit confusing to try and work out what's happening. That's a good point to look at any questions. Wait, are there any other questions before the last bit I mention in this? Nope. Okay. Then the last example of this is a bit gratuitous perhaps, but I think it's quite a nice example of how you can do other things with Make. We have in this Makefile a number of books which came with the kit, but we can bring other things in. So if we go back here, for example, we can get books off the web. For example, there is it gives the example of the picture of Dorian Gray from Gutenberg books, and we see that there's a plain text version of this file. Let's copy the link for that. Let's analyze that file as well. What we'll do there is we come back to our Makefile, and we Makefile. Let's also include a file doriangray.txt. How do we get that? Well, we want to get it off the web. So what we want to do, we just want to make sure that file exists. We can't express a dependency on this being on the web. So we'll say we just want to get this, make sure this file is present, rather than expressing the idea it had to be up more newer than something else. So what we'll say is curl. Curl is a command line program for retrieving things off the web. That's the URL that I just took from the Project Gutenberg website. Come back here and we say, oops, that we want that to be saved as doriangray.txt. Okay. Let's call that books.doriangray.txt, so it ends up in the right place. We'll save that. So now let's say make books.doriangray.txt, and it does its stuff. If we say that we want that to exist again, it doesn't repeat the download because it's already present. So that's a case where it's useful to have a target, a non-phony target without any dependencies. If you want to retrieve something from the web, a data file or a configuration file or a parameters file or a calibration file, something like that. So let's have a quick look at that that file. Oh, this has moved. So okay, well let's remove that. It's always useful to check these things somewhat by hand. So I think it's, if I remember correctly, it's curl minus L to follow locations. Is that right? Make. Okay, that's good. We do have it. So that's the file. Has stuff in it. And we go to the bottom and we discover that there's all sorts of Project Gutenberg stuff at the bottom, which is the license stuff, which is important to have, but we don't want to include it in our analysis. So we would like to get rid of everything after this line here, end of the Project Gutenberg line. So we can be a bit smarter in our Makefile and do exactly that. So nano Makefile. So this is us downloading the file. Let's be a bit clever and say we want to edit the file and tidy it up as part of the download. Let's use this edit. I think last time I briefly mentioned this thing. It said, which wasn't mentioned in the notes, but it's the sort of thing you should read the man page for, because it's always useful, especially in this sort of context. What we'll do is we want to find the line. What sed does is it copies its input to its output. It copies its standard input, hence the pipe character, to its standard output. But we want to and it allows you to edit it line by line as it goes past in ways that are simple but often useful in this sort of context. What we want to do is when we find a line which has the word end of the project in it, we want to stop copying. And we want to say, so what we're doing here is we're retrieving this file through curl. The pipe character is saying that what comes out from curl shouldn't be sent to a file, shouldn't be sent to the terminal, but should be redirected to the input of the program sed. What sed, the stream editor, does is it has an editing command here, which in this particular case is to quit copying whenever it finds a line like this. And so it copies its input to its output until it gets to that point, and its output is redirected to the this file $@ which is the target. Now this is a very long line, so we want to break it in two. If we just do that, it won't work because Make will regard that as being two different actions it has to give to the file. To make the file. So instead what we'll do is we will continue the line with a backslash so that Make will interpret that pair of lines as a single line. Parenthetically is a good point to mention because you'll almost certainly forget this very promptly, but I hope you will just remember this as a curiosity when this does bite you. Each of the lines that each of the lines of shell that Make passes to the underlying shell, if there's more than one action line, each is passed to a separate shell. So if you were to set an environment variable equals on one line, it wouldn't be visible on the next action line. I say that in order that you've heard those words. You'll almost certainly forget that, but I hope it will come back. It'll pop back into your head at some opportune time when you are otherwise puzzled. But what I want to leave, the way I want to leave this line is with just one action line here, which because of the backslash at the end, we're splitting over two actual lines just to make it easier to read. The operative curl is edited to make the actual target. We'll save that. We'll remove books.Dorian again and make that again. And now if we look at books.Grey.txt and go to the bottom, we find that, true enough, the sed command did do its work, and when it was copying, shoveling the input to its output, when it got to that line, end of the project, it stopped copying, and we ended up with the data we want, minus some stuff that we don't want. Sed is very useful that way. So now if we do make, then we see that because of the way we have, I'm getting tired. 5. Because of the way we have defined txt files, this DorianGrey.txt has been scooped up in this txt files, so that DATS has been now has a different definition. So now results.txt depends on all the DATs, including DorianGrey.txt.dat. So realise it has to make DorianGrey.dat. It knows how to do that because of the pattern rule. So it does that bit of work first before rerunning the result.txt. It was like make again. There's nothing to be done. So that little bit of extra gaudiness at the end. I'll get rid of this. I'll leave that line. It illustrates the fact that the make can do other things as well, such as retrieving things from the web, be they data files or calibration files or the like. You can break lines up over multiple make lines in that way. Sed, as I mentioned in passing, is useful for all sorts of little fiddly editing jobs like this. And because of the wildcard in this first line, that DorianGrey.txt, because it was in the right directory, would automatically scooped up into the set of files that were processed. So, going back to here, there is another chapter of the course on self-documenting Makefiles, which is sort of nice. And in fact, it showed another example of using sed, which is actually quite a good example in some ways, but which I think is more in the realms of cute rather than necessarily terribly valuable. So I encourage you to read through that chapter, because it introduces a couple of useful points, and it mentions sed as I did, in I think a rather tricksy way. But that brings us to the conclusions. And the conclusions really are just the same as the as we said in the introduction. You can essentially you can go nuts here. You can do all sorts of things. So the example mentioned in the conclusions is that you can also, and this is probably is a good example for you to go through afterwards. Just as you create a list of .dat files from the files ultimately in the books directory, you can similarly create a list of ping files and create a different makefile pattern rule to make ping files from the dat files. There's a good solid exercise to do here. You end up creating a dependency graph that looks like this, where the various .txt files are the dependencies of the DAT files, which are the internal dependencies of the ping files. And here we have a case where the all target, it suggests, consists of the result.txt files and the corresponding ping files, so that while you could also again do make results.txt, you might also use the sudo command, the phony command all, to phony target all, to say make all, and that would be code. That is you writing down this is what doing everything means, and that would be have as its dependency the txt file and all of the various ping files. Another thing to do is, something that quite often happens is, if you are collaborating with other people, then and I hope you do, then something that quite often happens is you want to give someone a bundle of the stuff that of your results perhaps, or a bundle of your of data files or something. There's a repetitive task that you have to do, and when you do that, you always forget, you've got to include that file as well, and you've got to include that file, and you've got to change that file before including it in the bundle. Do that in a Makefile. So have a phony target called bundle, which depends on bundle.zip, and bundle.zip will depend on the list of files you have to remember to include in that distribution bundle, written down once so that you don't have to remember it thereafter. And then actually below that include the possibly quite intricate set of steps involved in assembling those into a bundle for passing on to your colleagues. Don't write that down in a logbook. Don't write that down in a list of notes. Write it down in a Makefile, because that not only is a sensible place to put it, but it's executable documentation. It's stuff that you don't have to think about. You just say make bundle, and all the stuff that you at one time managed to get right is done again flawlessly, with all of the things that have to be included in that bundle, which have to be made, generated, possibly different versions of things will be made in the right sequence and bundled up in the right place. Get it right once and automate it is the model there. And there's a few other things that are mentioned in that last chapter, which are good solid advice. But that is the end of this session here. We got. I'll look back at the. There has been curl and wget. Not really. I tend to be able to remember the syntax for curl options, and I can never remember the syntax for wget, but that's just because I've ended up using curl more than wget. They both can do slightly different things in some cases, but for a lot of cases they're more or less interchangeable.
Curl comes on slightly more systems than wget comes on. So it's not unusual to come across a system which doesn't have wget on it, where you've got to install it, in my experience.
I think also I think curl is not included by default on macOS. It must be, because I don't think I made a default show. It doesn't matter. But I think that's a good point. That you might have curl on one machine and wget on the other. It's a matter of preference which one you use. I think that's about as done. Are there any other questions, or was that all transparently useful? Was that too long, too short? Is there anything more to say at this point? I think that Make is an unusual example of something where I can talk about it for now 2.5 hours and I've basically done all of it. I mean, that's just about all there is to Make. There are more complicated things you can do in the manual, but as I say, I think you should steer clear of those because they don't help and just make things look complicated. You will keep finding ways of using Make imaginatively. It's a much neglected tool because people don't realise until you point out, do you realise you can just use Make? They don't realise that how much you can do with Make. I use it all the time. Even in fact, when I'm trying to work out how to do something, if it's clear that there are, I'm working through some documentation about how to do this, that, and the other, I will tend to write a Makefile as I read through the instructions to do the bits of configuration of how do you edit this thing, how do you make this file from that file, just because that means I can see what's happening. And once I get it right once, it's in the Makefile and it stays right. I should probably stop there. Daniel, what would they say about next time?
Yeah, so next time we will be having a look at version control. So basically setting things up so that your a specific part of the file system on your computer keeps track of how the files change in a predictable way, so that you can go back and retrieve things effectively as a form of backup, where things are frozen in a state at a particular point in time. So to do that, we'll be using a system called Git, G-I-T, which you may well have encountered maybe tangentially already up until now through websites like GitHub, which are where very large amounts of collaboration happen with open source software nowadays. So that will be next week at 10 a.m. I will be leading that session. Otherwise, I don't think there is a lot to say about next week. Just being able to check that you can run git ---- version before then, and if you can't, let us know and we can try and help. Otherwise, the video for last week's lecture is currently uploading, so it should be available within the next half hour, hopefully. And the recording for this lecture will be available as soon as I can get it online. Any other questions or concerns before we finish up? Otherwise, we can finish 15 minutes early.
Even, I mean, there can be detailed questions or more expansive questions about the whole process. I mean, I'm sure that there's some things. Perhaps you're all stunned into insensibility.
Alright, well, if nobody else has anything, then thanks again for coming along today, and we will see you next week.
You won't see me because I'll be in the dentist's chair. Oh joy. But have a good time.
I'm sure you could get them to suspend your phone above.
Well, that might be a nice distraction. I will be there for about 3 hours. Okay, look. Have fun next time.